So let's discuss a question on entropy. This is a question on thermodynamics. So you have basically a source where you have 25 degrees water at 25 degrees. You want to convert that into ice at 2 kg water. Basically, you want to convert into 2 kg ice at minus 3 degrees. So this is the change you want. So with this, for this you have to remove some heat, and then you have a refrigerator which takes this heat and the work done by the motor and gives the total heat to the outside atmosphere, which is 25 degrees Celsius. So this is what the atmosphere, this is what the refrigerator does. Okay, so now the minimum work is something which is required. The minimum work will be produced when your entropy of the universe is close to zero. So that happens when you have a reversible process. So entropy of the universe is close to zero. That is what it will be produced. So now entropy of the universe, what are the components involved? I call this as source, this is the refrigerator, and this is sink. So entropy for the source, which is your evaporator, heat removed from your refrigerator cabin, source, then the refrigerator plus the sink. I just decouple this thing into zero. So this has to be, entropy of the universe always tends to increase, so greater than or equal to 0. If it is equal to 0, then it is the minimum work. So we will show that also. Now because some heat has been removed, and remember that the temperature is changing here, so entropy of the source is negative, but as the temperature is decreased, some amount of heat is removed. So this is the formula for finding out the entropy decrease. Refrigerator, because it's reversible, so entropy change is 0. And sink, because the temperature is constant for the sink, but the amount of heat added is Q plus W. From the figure you can see Q plus W, heat is added. So all this together, if I substitute, so dQ by T is the entropy change of the ice, plus Q by WT is equal to 0. So we'll come back to this equation, but this is, we term this as entropy change of the water. Okay, entropy change. So let's first calculate this, but let's calculate two things, because we need to know Q, the total heat that is removed from the water in order to make it to ice. So what is the total amount of heat removed, and then also the change in entropy. Okay, so we'll go step by step. So now first, water at 25, it becomes water from 25 to 0. Okay, plus the latent heat from water to ice, okay, at 0, and then ice at 0 to minus 3. So that is the thing. Okay, so there are three components, so let's substitute one by one. So this will, so water specific heat, so 2 kg specific heat of water is 4.18. okay, and 25 is 298 minus 273, so this is bringing water to 0. Then the latent heat of ice is mass into latent heat, which is given as 334 kilojoules. Everything is in kilojoules per kg, so we'll get everything in kilojoules. And then ice at, so ice specific heat of ice will be different, which is given as 2.108, and into it is, so 0 is basically, so change is basically 0 minus of minus 3, which is 3 degrees. Okay, so this is the total amount of heat, and this comes out to be 889.65 kilojoules. So this is one thing which we have found. Now let's come to the entropy change. Okay, entropy change. So let's find out the entropy change. Now first process where water comes from 25 to 0, there the entropy, there the temp dq for that is m specific heat into dt specific heat of water into dt by t, okay, plus for the second process where temperature is constant, so Q by T is ml by T. But for the third process, again it's similar to mass of specific heat of ice into dt by T. So dt by T is ln T2 by T1. So mass specific heat of water ln. So we can substitute. So directly let's substitute it here. Mass of water is 2, specific heat is 4.18 into ln. The water comes from 298 to 273, plus mass of is 2, latent heat is 334 by 273, 0 degrees. We have to substitute in Kelvin. Then plus mass of specific heat of ice is 2.108, ln comes from 273 to minus 3, which is 270. So all that, if I found out, I get 3.2026 kilojoules. So now let's come back to our equation here. So the decrease in entropy is minus 3.2026. Remember, it decreases, plus Q is already given. Q is, we have found out actually, 889.6. But remember, everything we are substituting kilojoules, by T has to be greater than or equal to 0. What does this mean? 889.65 plus W. So this is the sink temperature. Sink temperature is 25. So 298. So by 298, that has to be equal to 3.2026. So if I substitute, I get W less than or equal to, so 298 into 3.206 minus 800. So this value comes about 64.73. Okay. So this has to be greater than or equal to, because you take this that side and subtract, so W has to be greater than or equal to 64.73. So the minimum work what you have to do when everything is reversible, the minimum work you have to do is 64.73. So this is a very good problem which combines the entropy principle. So 64.3 is the minimum work you have to do by this second law of thermodynamics. Thank you.